So we graphed rational expressions. Now we're going to start adding and subtracting rational expressions. Adding and subtracting rational expressions. All right, so this is going to combine two of your most favorite things ever, factoring and fractions. Yeah. I know. Merry Christmas! Yeah. Yeah, I know. Oh, time out. Okay, so adding and subtracting rational expressions is basically adding and subtracting fractions, but those fractions are mathematical expressions. Let's start with just remembering how to add fractions, okay? Like if I have 2/3 plus 1/8. Do you remember what to do to add 2/3? Ooh, tricky. Yes. You get a common denominator. Yes, you do. Fantastic. What's the common denominator? Both the same number on the bottom. So can I just change this? What is the common denominator for 3 and 8? 24. So can I just do this? Okay. I gotta multiply something. All right. So what needs to be multiplied here? 8 here. Right, because in reality, what am I actually multiplying by? 1, because 8/8 is 1. Anything times 1 is itself. So I'm not actually multiplying by, I'm not changing the number, I'm just changing the look. So 8 times 2 is 16, and you told me that was 24. Okay, so what over here? 3/3. It's going to be 3/24. So is this 19/48? Right. Bottom number doesn't change, right? And 19 is a prime number, so that fraction does not reduce. Do you see a letter up there? Yeah. No one ever accused you of being psychic. Alright? So we remember how to do this? You remember how to do this? Yeah. Okay. You still don't remember how to do that? I'm going to make it just a little bit different. Alright.
I can do this.
Okay. What's going to be my common denominator?
6.
No. 12. 12. They both go into 12, right? 12 is the smallest number they both go into. Yes?
Yes.
Okay. So, what am I going to multiply this side by? 3/3. And that's going to give me 9x over 12. How about this side?
2.
So that's 10x over 12. We got 19 again. 19x over 12.
So the X don't mean anything. Not yet. Like that one.
Just wait.
Yeah.
So it's that down the road. It's going to be a whole nother problem.
No, it's going to be the next probably. Okay.
No, it's not. I'm not making it hideous yet. Yes. Yes. Alright, so we've already talked about common denominators. Try this one. I'm going to be, some of you are going to think this one's hideous. Alright. Try that one. What's your common denominator you're working with here? 24. Okay, so this one has to be 4 over 4, 6 over 6, 3 over 3. Alright, so I'm going to have 12 over 24 plus 30x over 24 minus 3x over 24. So what do I have here? 42x? Why not? Exactly. These are not the same right here. So I'm going to just be able to do 12 plus 27x over 24. Okay. Now, this is a fraction that will reduce. Because 12, 27, and 24 are all divisible by what? 3. If I divide this one by 3, what do I get? If I divide this one by 3, and this one, so we're going to write 4 plus 9x over 8. That's our final answer. That's our final answer.
No, it ain't that. No.
No.
It's not bad.
It's not bad.
It's not like so.
Not right now.
What we're going to focus on today, this is going to be where we're going to get, but with expressions. But today we're just going to focus on finding a common denominator, but with expressions. Okay?
Like this?
No, expressions. More involved. Level 2, yeah.
One more to go. When I get to level 3, I'm still in
Alright, so for today, we're just going to look at denominators, okay?
That means we
Alright, that's what I want you to look at today. Okay? Yeah, just look at that. And what I want you to do today is figure out what the common denominator is going to be. You will have to factor. Alright? This factors, what does this factor to? X plus 1, x minus 1. This one is just, that doesn't factor, right? Okay, nothing cancels. Alright, what does this fella have that this guy doesn't have? An x minus 1, right? Does everybody see? He's x plus 1, he's x minus 1. He's just x plus 1. So this guy has an x minus 1 that this guy doesn't have. Okay? So our common denominator is going to be x plus 1, x minus 1. So what does this guy need to be multiplied by? Right. You would have to multiply by x minus 1 over x minus 1. And that would be your common denominator. We're not going to do it today. We're not doing anything today. You can see, we're going to look at the front page of this. The front page, find the least common denominator, describe any restriction. Okay, that's what we're doing. We're doing this front page today. So, this is going to be our least common denominator. Now, what are the restrictions? What can I not put in for x? X can't be 1. What else? What would be my vertical asymptotes here? If I put a 1 in, I get a 0 right there. What about this side? Right. Those are my restrictions. Okay? Remember, you can't have 0 in the denominator. Those are our restrictions. Okay? Let's look at another one. And I'm not even putting an operation there. So I don't want you to think that we're adding or subtracting anything today. factor here? Nope. Nothing factors. X plus 4 doesn't do anything. X minus 4 doesn't do anything. So, what does this guy need that this guy has? He needs an X minus 4. What does this guy need? Right? So that would make our denominator what? Actually, X minus 4, X plus 4 would be our denominator. You can even say, hey, this is your least common denominator. What would be the restrictions? What could X not be to that problem?
4 negative 4.
Can I put that and everyone knows what I mean? Okay. Now we're not going any further today. That's where we're stopping with that. But they're not all just plus 4 minus 4 plus 1 minus 1. Let's put another one. And okay. How am I going to figure out what those factors are? I don't know what that guy actually has because that's a squared and that's just an x. What needs to happen over here? You got to factor it. Yes, you have to factor it. So, two numbers that multiplies equals negative 18 and add e7. 9 and negative 2. So I'm going to rewrite this. 3x squared plus 9x minus 2x minus 6. Again, if you still haven't figured out how to factor, you need to figure out how to factor. This next chapter is also full of factors. You have to figure it out. From like now to the end of time, you have to be able to factor. In trig, you know what trips up the trig students the most when we do trig identities? Factoring. Because you have to factor trig identities. You have to be so good at factoring numbers that you can replace them with trig functions and still be able to factor. You've got to know how to factor. It has to be second nature. Alright, so what can come out of the front group? A 3x, okay? That's going to leave x plus 3. What can come out of the back group? And that's going to be x plus 3. So this actually factors to 3x minus 2, x plus 3. Okay, so now let's compare them. What do we need here? What's going to be our least common denominator? X plus 3? Nope. There's no x minus 3 anywhere. What does this guy need? He needs an x plus 3. Right. So our least common denominator is going to be that x plus 3 times 3x minus 2. What are our restrictions here? We have two restrictions. What can x not be right here? Can be negative 3. What can x not be right here? What? 2/3. Right. 2/3. We're not adding, we're not subtracting today, we're just finding least common denominator. Okay? That's all we're finding. Alright, let me give you another one. This one, I'm going to need to try this one. try this one. You're going to have to factor this side. That side, nothing to factor. You're going to have to factor this side. So, we said this needed to be 6 and 6. So I'm going to have 4x squared plus 6x plus 6x plus 9. What can come out of the front group? A 2x. And I'm left with 2x plus 3. How about the back group? A 3. And I'm left with 2x plus 3. So this is 2x plus 3 times 2x plus 3. Okay? Well, that has a 2x plus 3. So do I need to multiply anything? Yeah, because how many 2x plus 3s does this one have? 2. And how many does this one have? This has 1. Yeah. So I would have to multiply this times another 2x plus 3. So my least common denominator. Can I save some time and just write 2x plus 3 squared? And what can x not be? Negative 3 halves. Negative 3 halves. Does everyone see how we got from here to here? Factored it. This one had 2, that one only had 1, so we had to do it again. And just to save time, I wrote the 2 right there instead of writing it all out. That's it. Oh, this is a good one. This is a nice one. Alright.
Sorry for the interruption. The high school makes sure that all students.
Okay, so x squared minus 3x plus 2, x squared minus 7x plus 10. What has to happen here? You have to factor both of them and compare the factors of both. Yes. Okay, so factor both and compare the factors of both. So, alright, so what did this one factor to? Okay, and what did this one factor to? Okay. So, what does this one not have that this one does? Right? So you would have to multiply times x minus 5 over x minus 5. And what about this one? What does it not have that one has? So you would be multiplying times x minus 1 over x minus 1. So what would that make the least common denominator? X minus 5, x minus 2, x minus 1. All three factors together. You see now, that, and that. They all three match now. So what are your restrictions? What can x not be? Yes. You see why this one has 3 instead of just 2? Right? Because in order for these to match, they had 1 in common. What if they didn't have any in common? What if this was like x minus 2, x minus 1, and this was like x minus 5, x minus 4? There would have been 4, exactly. We'd have 4 problems strung out there to be the least common denominator. Yes. Yeah, so, exactly. They have to have the same, whatever they have, it has to be the same, and then all of those are your least common denominator. Okay, look at your pages that you tore out, and she tore the pages for you. They're in the